Alright, let's look at the implementation of topological sort algorithm. Now here, inside this topological main function, I am going to call DFS function which we have discussed in previous videos with the source, vertex and the graph. Now inside this DFS function, we know that internal depth first search function will be called. If we look at that depth first search function call, it would be something like this. In depth first search function, before it returns, we are going to add vertex which just went to done state to a list called process list. Since we are going to use this depth first search function with many algorithms, we need to add vertices to the process list only if necessary. So to have that control, I have introduced another boolean variable called add to process list by default, and therefore in the topological sort function, before calling DFS, we had to set that add to process list to true, and also we had to create the process list as well. Now after this DFS function call, I have made that add to process list to false or its default value, and at this point our process list will contain all the vertices in the graph in topologically sorted order. Therefore, I am iterating through that process list and printing out the each vertex. Now let me run this topological sort function with the graph that we have discussed in the previous video. So inside this main function, I have created the graph correspond to the dress wearing example. So here I have added all the nodes and all the corresponding edges, and then I am going to call topological sort on this graph. Now let me run this example and see what is the outcome. Alright, here's the outcome. So if we look at the outcome, you will see that here we have topologically sorted vertex in our graph. Now the order appear in this example is a bit different from the order which appear in the previous video. Now this is due to our starting vertex, of course, but our main constraint, which is if we have edge from U to V, then U will appear before V, and that constraint will hold for this outcome as well. So that's all about topological sort. In the next video, we are going to discuss about a strongly connected component in a graph. Thank you.